Network devices. Now, probably the most basic network device used in an Ethernet network is a hub. Now, we don't use a lot of hubs out there in the real world any longer as we move to switches, but hub is still a basic concept. Data comes in, it goes out every single port. Let's use the wire in Ethernet star, connects devices that use BNC or RJ45 connector. I haven't seen one that uses BNC since probably about 1985. But RJ45 connectors, I have seen those and they're still around. Hub is easy to configure because there's nothing to do. You plug your cables in. You plug power in, you turn it on. That's the configuration. Not a whole lot. Traffic through a hub, anyone sends data in, it comes out every single port. Every single port gets that data, not just the one you're intending it. So it goes out to every port. Now there are different types of hubs. Now a passive hub is pretty old. I don't think you're likely to see that on the exam. It's not powered. So data comes in, still goes out every port. It's basically a multi-port repeater. It's just splitting the signal. It doesn't regenerate it. So whatever the length, maximum length of the cable type is, take the cable coming in, take all the cables going out, add them together, and you can't exceed the maximum cable length with that total of all the cables in a passive hub. Now we look at something like twisted pair, that's 100 meters. So you've got a 20 meter cable coming in, you've got an 8-port hub. Well, you use 20, you got 7 more ports. You've got 80 meters left between 7 ports. That's not a whole lot. So passive hubs, history, haven't really seen a passive hub since the days of ArcNet, which is too old for this exam. An active hub, though, regenerates the signal when it comes in. So it comes in off that 20 meter cable. You got 7 more ports. Well, it regenerates that signal. Every single one of those ports can now push it out up to 100 meters, assuming twisted pair. So you can run a great distance. So 100 meters on each cable coming out. It regenerates. A switching hub has another name, switch. Okay. Switching hub, data comes in, it reads the address, the physical address for where it's intended, what computer. And it keeps track of every computer that's connected and knows its address and sends that data only to the port that has that address. No one else. So it stays solely between those two computers communicating, does not go out to anyone else. Switching hubs or switches have some wonderful advantages. If you've got some bad guy on your network that wants to steal data, he doesn't see data unless it's intended for him, so he can't sniff the data. You have upstream and downstream simultaneous. You can't do that on an active hub, on a regular hub. You see just the term hub, assume active hub. A switch, you can have upstream and downstream simultaneously. In a hub, you don't. You only have one direction at a time. So you got much better bandwidth with the switch. You got upstream and downstream simultaneously. You have security with the switch. Now, an intelligent hub would still be a switch, just doing a few more added features, being able to filter or similar. Now, a bridge is an old device. Bridges pretty much existed before switches and after hubs. It was like a switch that had maybe 3 ports. And let's just look at this one we have here. We got 3 ports on it, and you dangle a hub off of each port, then connect the computers to that hub. So if we look at just that top segment there where there's 5 computers, if they send something out that's intended for another computer on there, it's going to go to every computer on that segment. It's also going to go to the bridge. The bridge is going to say, oh, it's intended for that segment. It's not going to forward it. Fantastic. Reduce bandwidth across the entire network. However, if someone wanted to send something from the top segment to the bottom segment, it would still go to everyone on the top. It would go to the bridge would see it and say, it's meant for another segment, and it would forward it out every other segment, not just the one it's intended. So it would flood everyone. Still better than using just a large hub, because it has reduced the amount of total bandwidth utilized, but sometimes not as much of an improvement as we would like. Switches, every computer gets their own port dedicated to it. So switches are those intelligent, smart hubs. It connects like a hub, but learns the MAC address and uses them, the MAC address being the physical address of each device, and uses them to make forwarding and filtering decisions. Benefits over the hub: data only goes out to the port for which it's intended, not to everyone. Huge one in terms of security. You have upstream and downstream simultaneously. That effectively doubles your bandwidth. Since it's only sending between a distinct pair that's communicating, you can use bandwidth between another pair to communicate simultaneously. So you have a 100 megabit switch, you got 8 ports, potentially you can run 800 megabits through that switch, whereas in a hub, you were limited to 100 megabits total. Huge difference. Another thing you may have on a switch is power over Ethernet. You might be able to power simple devices over Ethernet. But these are going to be very simple, low power devices. Routers work at layer 3 of the OSI model. Hubs work down at layer 1, switches and bridges at layer 2. Routers are up here at layer 3. They're a little more intelligent. They separate networks into separate nets or combine networks together for communication. You can split your large network into smaller, more manageable ones. An advantage of this: broadcast traffic. Now, we talked about switches helping with collisions. You basically got rid of collisions with a switch because traffic is only going to where it's intended. And you have upstream and downstream separated. That was wonderful. Collisions disappeared, but you still had broadcasts that permeate the entire switch. Routers. Broadcasts do not cross routers, so you reduce that traffic, making your network more efficient. You can create multiple networks, off of your routers, and you can communicate between networks only if a routing path exists, if the routers know how to communicate with each other. With wireless, we have access points, usually located up on the ceiling. Everyone with a wireless device will connect to the access point, but the access point then tends to be wired into your main network. So you connect to the access point, you authenticate, and you're connected to your main network and can communicate with the rest of the network as a member of it. It allows you to wander around, and most wireless networks allow you to move from hotspot to hotspot on the same network without ever losing connectivity, so you can wander around your entire area. A modem. Modem is a modulator-demodulator. Converts digital signals from the computer into analog signals that can go over the phone line. And at the recipient's end, it takes that analog signal from the phone line, converts it back to digital for the computer, and then works the other way, going back for communication. So it's a modulator-demodulator. It can be an internal modem like we see on that card to the right, or it can be an external box like we see on the one on the left. And it can be connected by a serial port, more traditional by a serial port, or in the case of newer ones where modems still exist, probably by a USB cable.